Hello everyone. So today we'll go over fraction subtraction, and similar to the fraction addition, we also have three different cases. So case one, we'll look at odd fractions having the same denominator. So for example, if we have two fractions, a over b subtract c over b, so you can see that both of fractions have the same denominator b. So in this case, the answer will have the denominator as b, and the numerator will be a subtract c. Okay, so we'll go over some examples. The first example, we'll see two fractions here. So 11 over 17 subtracts 9 over 17. Both fractions have the same denominator 17. So for the answer, we'll write 17 at the bottom part. It is a denominator. And for the top part, it will be 11 subtract 9. And the answer is 2 over 17. Okay, so the case one is very easy and simple because both of them already have the same denominator, so you don't need to do much work. It's just like one step work, like take two numerators, subtract each other. The first one subtract the second one, and then we keep the denominator the same as the two original fractions, and that's the answer. Okay, and the case two also similar to fraction additions, like all fractions have a different denominator, but one of them is a multiply of all others. So we'll start with the example. Let's say we have a 1 over 2 subtract 3 over 10. So in this case, both fractions have a different denominators. The first one has a denominator of 2. The second one has a denominator of 10. So they are different. So we cannot just subtract the top part and then keep the bottom part like the case one, right? So we must make them the same denominator first. And in this case, you can see they have a different denominators, but one of them is a multiply of the other. So in this case, 10 is a multiply of 2. Why? Because 10 equal to 2 times 5, right? And in this case, similar to fraction addition, the least common denominator is the greatest denominator, and it is 10, right? And because it is 10, so for the second fraction 3 over 10, you don't need to do anything. Okay, just keep unchanged. And we only need to change the first fraction 1 over 2 to become a new fraction with the same value as 1 over 2, but having a denominator of 10. So same denominator as the second fraction. So how can we change 1 over 2 to become a new fraction with a denominator of 10? So in this case, we only need to times both the top and the bottom part with 5, right? Because we are trying to make it to become a new fraction with denominator of 10. So 1 times 5 is 5, 2 times 5 is 10. So now we have a new fraction with the same denominator as the second fraction, 3 over 10. So both of them have the same denominator. So now we can subtract them to each other. Okay, so 1 over 2 subtract 3 over 10 equal to 5 over 10 subtract 3 over 10. And 5 over 10 come from 1 over 2 here, right? Because we are trying to make them the same denominator. And now, similar to case 1, just like the case 1, so keep the bottom part as 10 and then subtract the two numerators to each other. So 5 subtract 3, always the first one subtract the second one, 2 over 10. And the answer is 2 over 10. But 2 over 10 is not the most simplified fraction, because 2 and 10, both of them can divide by 2, right? So how to simplify them? We just 2 is already prime number, so we cannot write it as a product of prime number anymore. But 10 is not a prime number, and we can write 10 as a product of 2 and 5, and both 2 and 5 are prime numbers. So we just write it as a 2 times 5, and because maybe number 2 you can write as a 2 times 1. It is a prime number, so just write as a 2 times 1. So both the top part and the bottom part have a number 2, so we cancel out number 2. And then the left thing is 1 over 5. And it is a final answer. Okay. Now we go to case 3. Case 3 is also like fraction addition. For the case 3, so all fractions have a different denominator, and none of them is a multiply of all others. Okay, and in this case we also have to find the least common denominator by using the product of prime numbers. Okay, so let's take an example. Let's say we have a 1 over 2 subtract 1 over 3. Okay, so this case, for this example, we have two fractions, 1 over 2 and 1 over 3. Both of them have a different denominators, and none of them is a multiply of the other. 2 is not a multiply of 3 because the 2 cannot divide by 3. 3 is not multiply of 2 because the 3 cannot divide by 2. So in this case, how can we find the least common denominator? So we write each denominator as a product of prime numbers. So here 2 is already a prime number, so just write as 2 times 1. And 3 is also a prime number, so just write as 3 times 1. And the least common denominator equal to the product of all different prime numbers with its highest power. Okay, and in this case it's just 2 and 3. 1 we don't care because whatever time 1 is just itself. So, and the highest power of prime number 2 is 1, because we only have a one number 2. And then the highest power of prime number 3 is also 1, because we only have a one number 3. Okay, for each denominator. So, and the answer is a 6. So now the common denominator is a 6. So we need to change both fractions 1/2 and 1/3 to new fractions with the denominator of 6. Okay, so how can we change 1/2 to become a new fraction with the denominator of 6? So we just times the bottom part with 3, and because we times the bottom part with 3, we need to times the top part with 3 as well. So it will be 3/6. And similar we do for 1/3. So we need to convert this one to a new fraction, change this one to a new fraction with the denominator of 6. And in order to do so, you need to times the bottom part with 2. And because we times the bottom part with 2, we need to times the top part with 2 as well. So the answer is a 2/6. So now both of them have the same denominator, so we just subtract them for with each other. So just the first one subtracts the second one, and it will be 1/6, because it's a 3 subtract 2/6. And the answer is a 1/6. So this example is pretty easy. We go to something a little bit more complicated. So let's say we have a 19/20 subtract 4/15. Okay, so in this case we can see both of them have a different denominators, and 20 is not a multiply of 15. 15 is not multiply of 20. So none of them is a multiply of each other. So we need to find LCD by using the product of prime numbers method. So first we need to write each denominator as a product of prime numbers. Okay, and 20, how can we write 20? So 20, we need to use the tree method like we used in previous lessons. So 20 can divide by 2, right? 2 is the first prime number, and 20 divided by 2 is 10, right? But 10 is not prime number yet, so we need to keep going, break it down more. So 10 can divide by 2 because it's an even number. So even number always can divide by 2. So the first number you always think about is 2. So 2 is a prime number, circle it. And 10 divided by 2 is 5, right? And now 5 is a prime number, so circle it, and that's it. We don't need to do anything else, because now all of them are prime numbers. So 20 can be written as 2 times 2 times 5. And because here we have a 2 number of 2, so you can write as a 2 power of 2 times 5. So the power of number 2 here is 2. The power of number 5 here is 1. Okay? And similar, we do the same. We do for the same for 15. Okay? So 15 is easier, because 15 cannot divide by 2 for sure, because the ending number is 5. It's an odd number, so it cannot divide by 2. So okay, so if it's not 2, so try with 3. So 15 can divide by 3. Okay, so 3, and 3 is a prime number, so circle it. And 15 divided by 3 is 5. Okay, 5 is also a prime number, so circle it. So now we have all prime numbers. We stop here. Okay, so we can write 15 as a 3 times 5. Okay, and because we only have a one number 3 and one number 5, so both of them have a power of 1. Okay, the highest power of number 3 here is 1, and the highest power of number 5 here is also 1. So now the least common denominator, LCD, equal to the product of all different prime numbers. Okay, all different prime numbers. So here we have a 2, 3, and 5. They are all different prime numbers with the highest power. Okay, so the highest power of number 2 here is 2. So most of you power 2 here. The highest power of number 3 here is 1. Okay, so we don't need to write anything. And the highest power of number 5 here is also 1. Because why? Because when we break down number 20, we only have a one number 5. When we break down number 15, we only have a one number 5. Okay, so each of them only have a one number 5. So it means the highest power is a 1. Okay, because only one number 5 in each denominator, 20 and 15. Okay, so now, so after we write it, and now we just do some calculation. 4 times 3 times 5, and the answer is a 60. Okay, so now we already determined the LCD is a 60. So we need to change two fractions above to two new fractions with denominator of 60. So we'll change 90 over 20 to become a new fraction with denominator of 60. So how can we do that? So from 20 we need to change to 60. So it means we need to times it with 3. And because we times the bottom part with 3, we need to times the top part with 3 as well to keep the original value. Okay, and it will equal to 57. 19 times 3 is a 57, and over 60. And similar, we do the same for 4 over 15. How can we change this? How can we change 15 to become 60? So we need to times this one with 4, and because we times the bottom part with 4, so we need to times the top part with 4 as well. And the answer is 16 over 60. Okay, so now both of them have the same denominator, so we only need to subtract to each other. Okay, and the answer is 41 over 60. And if you check, this fraction is already the most simplified fraction, because 41 is a prime number. So we cannot 41 and 60 does not have any common factor. You cannot break down 41. Okay, because we cannot break down 41 as a product of prime numbers, so we cannot do anything with 60. We cannot cancel anything from 41 with anything, you know, from 60. So that's why it's the final answer. Okay, so yeah, so that's the lesson about fraction subtraction. It's just the same way, the same cases, the same way to do like fraction addition. The only the different thing is about mixed number. Okay, a little bit more complicated is mixed number subtraction that we'll do in lesson 7. But for now we are good, so to stop. Bye bye.